Oke, baik. Izin mungkin Pak Jeff, kedengaran suaranya Pak Jeff? Izin?
Kedengaran.
Oke, baik. Terima kasih Pak Jeff.
Kedengaran.
Kemudian Pak Profian, izin?
Ya, siap.
Mungkin sudah kedengaran suaranya. Oke, baik. Terima kasih Profian. Kemudian Pak Erlangga, mohon izin. Bisa terdengar?
Ervin.
Ya, terdengar Pak ya, Pak Erlangga. Oke.
Tes.
Kemudian
Ervin kedengaran ya?
Prof. Ya, Prof izin.
Siap.
Kedengaran Prof ya? Siap
Oke,
Prof, kedengaran. Oke. Oke, baik. Mohon izin Bapak Ibu, mungkin acara akan segera kita mulai. Saya mohon izin dari host, silakan Astri untuk dimulai.
Oke. Assalamualaikum warahmatullahi wabarakatuh. Greetings to all of us. The Honorable Professor Sopaheluwakan, Coordinator of Environmental Disasters for Sustainable Art and Resources. The Honorable Mr. Dr. Jeffrey Malaihollo, the Chairman of Edenfield Energy PLC. The Honorable Mr. Erlangga Surtama, PhD, the Vice President of IAGI. The Honorable Mr. Hervin Samalihu STNN, Doctor Candidate of Gajah Mada University and also the Chairman of IAGI Maluku. And the Honorable Professor Adi Maulana, Professor of Geological Engineering at Hasanuddin University. And all participants here, good afternoon. First of all, thanks to God who has given us this blessing and mercy so that we can gather here to this amazing international webinar without something will happen. Ladies and gentlemen, I'm Astri. As the host for today, we will guide this event on behalf of the committee. I would like to welcome you all to this international event. So we are going to talk about Moluccan for Indonesia, sharing knowledge with Moluccan Geoscientists, with the title of this webinar is Metamorphic Rocks in Banda Arc and the Origin of Moluccan Island. So ladies and gentlemen, before starting our webinar today, I would like to read the ground rules during the event. Ladies and gentlemen, this is the webinar rules. The first one, make sure your computer, PC, or device connected to the internet. The second one, moderators fully organize the running of a webinar. Participants are requested to not to activate the video and microphone feature, or the host will set a mute mode to participants' videos or sounds. The question and answers are open in this discussion session. However, When the webinar takes place, participants can ask the question by using the chat room by mentioning instance_name_the questions. The last one, if you have further questions for the speakers after the event, please contact our email, iagimaluku@gmail.com. So, ladies and gentlemen, I would like to invite the chairman of IAGI Maluku for give us the welcoming speech. Dear Mr. Hervin Samaleo SPNN, Doctor Candidate of Gadjah Mada University, the time is yours.
Okay, thank you very much, Astri. Assalamualaikum warahmatullahi wabarakatuh, and good afternoon. Honorable Vice President of Indonesian Association of Geologists, Pak Erlangga Septama, PhD. Honorable speakers for today, Prof. Sopaheluwakan and Pak Dr. Jeff Malaihollo. Honorable all of health of agencies and departments who are attending the webinar. Esteemed colleagues, all senior geologists or geoscientists of Indonesia and the advisors of IAGI Maluku. Esteemed local government agency of Maluku, Geoscience Universities, our moderator, Prof. Adi Maulana, and participant of the webinar. Welcome to international webinar with the theme Moluccans for Indonesia, sharing knowledge with Moluccan geoscientists, conducted by IAGI Commercial of Maluku. The topics of this webinar vary and are related to the tectonics, economic geology and mineral resources, marine geology, and engineering geology. This second webinar session will presenting two outstanding Moluccan geoscientists, Prof. And Pak Jeff, and we'll share about the tectonic, metamorphic rocks, and economic geology. In the first webinar session, Dr. Jonathan Funnell has deciphered the mechanism of slab rollback extension and rapid exhumation metamorphism. And this is quite different with previous concept promoted by Audley Charles and followed by Barber and Mike Earl in the early of 1918s. So several collections of early publication and evolution of the tectonic concept and metamorphism in the northern Banda art, especially Seram and Buru, has highlighted of violet abduction concept. This concept was then strengthened by the slab rollback, slab brick mechanism, and opialate squeeze up by researchers from the Tokyo Institute of Technology, and then followed by Honol et al., who improved it with the Banda slab rollback. The point is that the discovery of Sopaheluwakan in 1990 in East Timor has changed the established view of the continental metamorphism and remodeled the order of thought from the first concept adopted by Charles, Barber, and Mike Early in 1980s. Prof. Yan will speak on this subject and the implication for mineral and hydrocarbon exploration in Banda Sea and its surroundings, as well as uncovering various oceanometeorological phenomena to the human race survival. On the other side, investment in mineral resources in regards to process, risks, and rewards should be fully known by geoscientists. Take a look at copper mines in Wetter Island, high basal metal prospect in Roman Island and Haruko Island, and the distribution of other economic deposits in Maluku. These sessions will be presented by Pak Dr. Jeff Malaihollo, where the presentation will cover view on minerals and mining industry from investment perspective in order to equip geologists or geoscientists, especially those in economic geology, to have a context of the work and what should be doing in the industry. Hopefully, this session will add our insight regarding investment in mineral resources. In the name of IAGI Maluku, I would like to express my deeply gratitude to Prof. Yan and Dr. Jeff Malaihollo for your attendance as Moluccan geoscientists for this outstanding webinar. Thank you.
Thank you, Mr. Hervin, for the welcome speech. The next one, we will hear the welcoming speech and also to open officially this international webinar, dear Forum Vice President of IAGI, Mr. Erlangga Septama, PhD. The time is yours.
Okay, thank you, Astri. Good afternoon, everyone, the distinguished speaker and moderators, my esteemed colleagues, ladies and gentlemen. I am representing IAGI, would like to welcoming all of the participants to this international webinar. We very much appreciate your attendance here. These workshops, especially designed by IAGI Pemda Maluku, to share the insight and view from well-known expertise. So today, we are very honored to have Professor John Sopaheluwakan and Dr. Jeff Malaihollo with us, and also Professor Adi Maulana. Overall, this webinar series aim to share the knowledge amongst colleagues about the vast topics in tectonic, economic geology, petrography, geotechnics, and marine geology, more specific to the Eastern Indonesia and especially in Moluccan area. We knew that Maluku in particular is the area with the most, most complex geological setting in Indonesia. Everything is happened very fast here, like a blink of eyes. Well, of course, in a geological time scale. Last week, we have learned from Professor Hall and Dr. Pono in the first webinar, a story about the Moluccan seas, which is a product of arc-to-arc collision between Halmahera and Sangihe arc, which just started around 11 million years ago. And anytime later, could be disappear, maybe in another 5 million years. So, well, we can imagine of how dynamic it is. We hope this knowledge sharing session and of course discussion will strengthen our knowledge and raise awareness on the matters concerning of the theme selected that probably see as the most related issue in this region. This is also aligned with one of the IAGI programs is to establish a local champion or expertise in every province. Hopefully, besides the main objective to enhance our technical knowledge and capabilities, this opportunity also give a chance for participants to meet and under the guidance of the committee, exchange view and strengthening their networking. So let's make this event also as a networking opportunity between each others. As here we had a participant not only from Indonesia, but from also around the world. Time may be limited and may not allow us to exhaust all we have here, but I think this is will help the participant to build the networks and may help each other to exchange view far beyond 3 weeks where the session had been planned. We also have among the participants a vast knowledge that I sincerely hope will enrich the discussion to benefit of all. I see here present with us Pak Awang Satyana, Pak Justi Siwabesi, Pak Indra Badri, the seniors. So I wish we will take the advantage also of this opportunity. So without any further ado, and to keep the schedule in a timely manner, I would like once again to thanks to all participants for their valuable presence, without which the workshop maybe would be produced. And I would like to thank to the speakers and moderators who have willingly lending their time and accepting our invitation to share their knowledge and also lead the discussion. Okay, thank you very much and enjoy the presentation.
Thank you, Mr. Erlangga Septama, PhD. All the blessed participants, we will start our webinar today, and Mr. Prof. Adi Maulana will take over this event as the moderator.
Okay, thank you, Astri Gloria Larui, for your time. Okay, all webinar participants, good afternoon. Thank you for your time for joining this webinar. First of all, I would like to introduce myself. My name is Adi Maulana from Geology Department, Hasanuddin University, Makassar. I hope that you can all hear me very clear. I'm very happy and feel very honored to be your chairperson in the second day of IAGI Pemda Maluku event. And then I would like to take this opportunity to express my gratitude to our distinguished presenter today. We will have Professor Sopaheluwakan and Dr. Jeff Malaihollo for their time and their knowledge this afternoon. And I don't want to spend more time because we have a very limited time. So let me introduce our two presenters today. Our first presenter, Professor Sopaheluwakan, obtained his undergraduate from Geology Department, Bandung Institute of Technology. And then he got his master's degree in structural geology and explorations from International Institute for Geoinformation Science and Earth Observations, ITC, in Delft, the Netherlands. And then he obtained his PhD in geology from Free University Amsterdam. He's a research professor of geology at the Indonesian Institute of Science, or LIPI, and he chaired the Development and Environment Commissions of Jakarta Research Council, and is now coordinator of the Center for Environmental Disaster of the Institute for Sustainable Earth and Resources in Universitas Indonesia. And then he has also a very long history of position. One of them is as a deputy chairman of scientific services on Indonesia Institute of Sciences in 2006 until 2011. And then he is also a president and co-founder on Indonesia International Institute for Urban Resilience and Infrastructure from 2014 until now, and then coordinator for environmental disaster for sustainable earth resources in Universitas Indonesia from 2018 until now. And then our second speaker, Dr. Jeff Malaihollo. Dr. Jeff obtained his bachelor degree from the University of California, Santa Barbara, and his PhD from University of London, researching the geology and tectonic of Bacan Island. And then he worked as a geologist for several mining companies, including Billiton, Rio Tinto, and Newcrest, mainly in new business venture until early 2000. He is currently a non-executive chairman of London, and then he's also a director of Canadian listed Copper Lake Resources, this base metal and gold asset in Ontario, Canada. He is also busy with language training program Bahasa Basudara. Okay, before we start our session today, I would like to share the information from the committee. We will have 50 minutes or 50 menit for each speaker. The first speaker will be Professor Sopaheluwakan. He will deliver his topic today entitled Metamorphic Rock in Moluccan region. And then after Professor Sopaheluwakan presentation, we will have a 10 minutes break. And after that, we will have another 50 minutes. The second speaker, Dr. Jeff Malaihollo, with the topic economic geology. After that, we will have 20 minutes for discussions, and then 10 minutes wrap up and closing, and then 5 minutes photo sessions. I think that all for the introductions. I would like to invite our distinguished speaker, Professor Sopaheluwakan. Professor Jan, are you with us?
Yes.
Yeah. Okay. Thank you, Professor. Time is yours.
Okay. Thank you, Professor Adi Maulana. Distinguished participants, colleagues from IAGI and others. Good afternoon and good morning there for Jeff in Europe. I would like now to immediately share the screen so then we can have more time for discussion later on. Okay, is it already visible there, my first slide?
Yes, yes. That's...
Okay.
Go ahead, Pak.
Okay. Okay, now I dare to go beyond just conventional geology. Then I will go further into more or less sustainable Earth. Especially, I will be addressing what will be the impact of the tectonics in Wallace area, particularly in the Banda arc, and then what will be the impact on the global climate, dynamics there. So then, because I've been also not only in classical or conventional geology, but I've been involved more intensely in the Earth system science. That's why the title of my talk will be Metamorphic Rocks in Banda Arc, which is of course my basic. And then what we go beyond, we go beyond the metamorphism and tectonics, and how will be this tectonic development in the Banda Arc is impacted in our global climate. So this is more or less the division or my outline. So I will start talking about what will be the driving force behind this. That is especially with the invent of the plume tectonics in the early 90s. That then we get more perspective on the on the global tectonics, not only from the modern plate tectonics, but then since the advent with the seismic tomography, experimental petrology, and also other advance in geoscience, then especially the people in Japan, Professor Shigeru Maruyama and their colleague, they promote this plume tectonics, and of course people and all the scientists in the world. Then I will present mostly my experience, the discoveries of especially how actually the role of the ophiolite, role of oceanic crust, of oceanic lithosphere in forming the Banda Arc in particular, and also of course the Eastern Indonesian region, especially in around the Wallace areas. And then from there, I would see not only the paleogeography, what Robert Hall has already explained you, but then we would like to bring you also to see what will be the paleoceanographic implication. So I will also, of course, appeal and bring you more to these more environmental issues, paleoenvironment, paleoceanography, and so on. And then a little bit of just trying to, what do we call it, to unravel again, to put it again, what I have been written in 1993 about what will be the impact of the discovery in Timor, especially on the metamorphism, which I have been working on, and on the exploration, especially on hydrocarbon a little bit, and also about on the gold exploration, especially in the ophiolite areas. And then we finally come up with what will be the global oceanometeorological impact because of the dynamic in the Indonesian seaways, what we call it Indonesian seaway, which presently now in this Eastern Indonesia and the Wallace areas. And finally, I will be just sharing here what will be the way forward. So this is actually, I think everyone knows about this, that the development of the global tectonic from plate tectonics, and with the infant and the advancement of the seismic tomography, experimental petrology, then we come up with the plume tectonics here, with that you have a whole Earth tectonic, you have here with the sinking of the cold slabs along the subduction zone, and then they are flattened here around the lower mantle, upper mantle boundaries, and then that creates some kind of upwelling here in the Atlantic as well as in the Pacific here. So this is again just to remind you of the picture of this the African super plumes, as well as also in the Pacific super plumes here, showing you here the areas of upwellings and also the downwelling here, the blue one, the cold slabs down sinking under the continents here. So these are just some development, especially driven by the Pacific super plumes here in the middle of Pacific here, from the Mesozoic time here. Then you have some kind of migration of these what do we call this oceanic plateaus and so on, and then you finally end up with the stranded ophiolite splinters here in Indonesia and other in the Circum-Pacific as well and other areas there. So actually, this is the thing that people discard or didn't know exactly what will be one of the role of these super plumes, and then we come up with what we are going to talk about today here, especially from my perspective. And this is just some old pictures of the seismic tomography here, crossing from Kalimantan to Papua. You have here some sinking slab, cold slab with fast velocity of this, and then you have here also beyond under the Southeast Asia, you here have big blobs of these cold slabs here, and the rest, of course, we have listened last week from Robert Hall about these U-shaped cold slab here under the Banda Sea. Yeah, similar situation here, crossing from Timor. Here you have the old slab, and then it flattens down in the upper mantle areas, and then this is the older one, which is sinking under the Asia and Pacific Sulawesi areas. So our attention will be around the what we call the Wolossi areas, in which you have very complicated juxtapositions of the oceanic plates, oceanic crust, also continental crust, as well as the emergence of island arcs and so on. And it's quite complex. I think last week Robert Hall has mentioned and explained us about this. And what is present here, you see here quite a number of old Jurassic oceanic crust here, which are surrounded by the younger ones here in the Argo Abyssal Plain, Wharton Basin, and so on. And then strikingly here, you have here some discontinuity. This makes different seismicity behavior in Sumatra with respect to Java, for example. Here you see very clearly, you have a deep earthquake here north of Java, while you don't have it in Sumatra, and this of course creates different seismicity and different earthquake pattern, and also fault zone, as well as of course the tsunami characters here present in southern Java to eastern Negara and then Maluku. And another one here, you have some kind of discontinuity of the middle and deep earthquake focal epicenters here, and you have some kind of here some a little bit of discontinuity which may impact in the later on what we call the slab break off, which explain why, for example, the islands eastern of Timor here emerged, and then that created the ophiolite emplacement here. So here is the stranded ophiolite, originated from the old Tethys Ocean here, Pacific and Indian Ocean, and then this driven by the dynamic from the Pacific superplumes here. Then, okay, I think up to now the debate or the enigma of the crust ophiolite relationship here, especially in the Banda Sea, remains continue, and then I will explain it. First one, when we found out and we discovered that the young intraoceanic crust here somewhere in the northwest of Australia started the origin and the evolution of the metamorphic rocks, especially found in Timor as well as in the eastern islands of Timor, what we call is Timor, Tanimbar, Orogen areas. Of course, that is different to the one which are present in northern Banda Arc here. I think last week John Ponal has explained it. So when I started my PhD work, so then this was a situation that you have some kind of enigma or discontinuity of these magnetic stripes, and then this seems to be there is some kind of missing link between the oceanic crust, the old oceanic crust here in the Banda Sea, South Banda Sea Basin, and also the Argo Abyssal Basin. And then surprisingly and fortunately also that the age of the ophiolites here, it's more or less fixed, or it may represent the missing link between the age of the Banda Sea here, South Banda Sea, and also the Argo Abyssal Plain. That was the hypothesis that we have to prove it later on, especially when we are talking about the origin of the Sawu basins, and also, of course, the Weber Deep, whether they are related and something like. Of course, when you follow the hypothesis of this slab rollback, then this seems to be very clear. But I think this remains further for the research. So the tectonostratigraphic of Timor, I modify here after Tony Barber, and then you see here the quite unique position of the Moody's complex, the metamorphic rocks exposed in the in the backbone of the Timor Islands from the west until the east. Then we found out that the peridotite, part of the lowermost part of the ophiolite, is tectonically overlaying the so-called Moody's complex, and that is more or less also a similar situation that we can find, for example, in Oman, Newfoundland, Timor, as well as you see in the things that we are not talking about. So these are more or less the stratigraphy in Timor, and we compare it with Newfoundland, and based on several previous workers in Timor, especially when we are dealing with the metamorphic rocks. This is Michael and then this is my past work 30 years ago or 31 years ago. So what is interesting here is that we are dealing with some kind of tectonic windows, that you have here the peridotite here overlying tectonically or structurally the underlying here the metamorphic rock, which are interestingly, they have not normal metamorphic gradient. You have high grade rocks here, high immediately below the peridotite, and then it goes further, going into lower grade metamorphic rock as they go further away from the tectonic contact here. This is the cross section of these areas that's showing you more or less the structural thickness is about 1 kilometer thick. So, but then you can see here is very strikingly that the inverted metamorphic zoning, as well as quite rapid metamorphic grade changes from the top to the bottom. Both you can find it both in Mutis mountain as well as in the Miomafo mountain there. So another thing that we found out there is that you have quite a striking high-level melanitic zones as well as the low-level melanitic zone that explains you and can be an indicator how this hot ophiolite slab is in place, and that creates overprinting of the metamorphism in the while it is what do you call the heat was also transmitted through the fluids, carbonic fluids, as well as the aqueous fluid, as we will see it later on. Oh, what's happened? Okay. So so I was using also fluid inclusion studies, quite intensively here. You can find it in quartz, in plagioclase, as well as in garnet areas. But then from the fluid inclusions, we can reconstruct there how is the pressure temperature histories of the Moody's complex. Here is showing you quite rapid uplift of that during because of the intraoceanic crust thrusting, and then this is where you have this abduction of these hot oceans of ophiolite slab, and that is proven by the, you see here, this is the high level metamorphic rocks, and then this, as you go further deeper, you can see quite a systematic change from the carbonic fluids into the mixed carbonic and aqueous fluids, and then as you go further down in the structural level, you have here the aqueous fluid. So and then this we use that you see here that as the deformation goes on with the melanisation and so on, then this is quite clear that we are dealing with what we call the isobaric metamorphic zoning. But then as we go further down away from the tectonic contact with the peridotite, you have lower grade metamorphic rock, as well as here you have the low level melanite zone. In the low level here, you can still find the relics of the pillow lavas structure there. So indicating that we are dealing with the uppermost part of the ophiolites, and then which is overlain by sediment, which are now already converted into high and medium grade pelitic rocks, as well as the amphibolitic rocks. So then this PT diagram shows you how the peridotite is uplifted, the hot peridotite uplifted while it is cooling, and then it creates this isobaric inverted metamorphic zoning. So the way it is done, it was done that we can explain, and I was proposing this, what we call the hot iron tectonic mechanism. Here you have the hot peridotite emplacement while it is creating the high level mineralization and also the low level. But then at the same time, you have the circulation of the carbonic fluids. And here is you have the mixed fluids, and then at the low level, you have the more aqueous fluid. So this is quite important, not only that the fluid is also an agent for heat transfer from top to the bottom. Otherwise, the rocks will not be, will be metamorphosed, and this will have some consequences on the mineralization. I will explain it and go back later on, for example, the strikingly discoveries or the occurrences of gold, for example, in ophiolite complexes. I will come back that later on. So in summary, that the way the Mutis complex was formed is that we have here in northwest of Australian or Gondwanan continent. Here you have short-lived mid-oceanic ridge here, and then when it is about 5 to 10 million years old, and then it is closed, then it is where the oldest metamorphic rocks here, as is reported by Mike Earl, for example, was formed. That was the initial part of the Mutis complex was formed, and then it was abducted here during the Miocene, and then again it is abducted again when you have here the Atapupu ophiolite there together with, for example, the Oikusi one. So when talking about the Timor, then you are dealing with the repeated abduction because of the northward drifting of Australian continent with the overlying complexes of the stacking of all these unmetamorphosed as well as the metamorphosed part of the area. So but then I'm trying to reconcile to what Robert Hall has already reconstruct here about the Jurassic paleogeographic reconstruction here. It is clear here that I don't know whether how did he make this kind of short-lived mid-oceanic ridge, and this is where we suspect that the Mutis complex was originally or initially formed, and then it moved further north, and then the ophiolite, then it was formed as part of the old Banda arc. Okay, that was Timor, and then we move further into the northern part of Timor. That was the Mutis complex. Now is in Atapupu, northern coast of Timor, and similar situation here. You see here the uplift of the peridotite here in the northern part of Atapupu, Atambua until Batugade in Eastern Timor. And then this is the PT path of the underlying metamorphism. You see here more or less a similar situation, the Barovian path, what we found here also in Kaubobo area. So that means there is some kind of striking genetic relationship between Atapupu and the Kaibobo one. So now we go further on, then now we rely on Kadarusman and the group from the Tokyo Institute of Technology, especially when explaining the uplift of the smaller island from Leti, Moa, Sarmata, and Dai. A similar situation was found as it is found in Mutis complex and also in Atapupu areas, that basically we are dealing with the antiform of the ophiolite overlying the metamorphic rock, the inverted gradient with the inverted gradient rocks. And then he explains that as a result of this squeeze mantle, hot mantle materials here, and then that creates also what we found in Leti, the highest, the youngest high pressure metamorphic rocks found in Leti Island, for example. That was the explanation of our colleague from Tokyo Institute of Technology and Japan, other colleague from Japan, how the metamorphic zoning there found there with two steps of formation. One is the overthrusting of these squeeze mantle materials, creating the high pressure and also the hot gradient metamorphic, and then followed by the updoming because of the slab break off here, and we can find here also as the beta thrust. So this is the mechanism of how more or less the situation what we found in Timor, but then now is complicated and modified by the slab break off because of this subducted continental material from Australia. So then here we are dealing with the eastern younging of the emplacement of the ophiolites slivers here from Atapupu and also in near Dili, Iliu areas, and so until this Leti and Sarmata and Dai and so on. So this is what can be concluded by the investigation by Kaderman and his group. Now we go to the Seram model situation, where we suspect that more similar situation, that you have the emplacement of hot ophiolites here in Piru Bay areas, in Kaibobo, and also in Piru areas. More or less is a similar situation here. We have hot ophiolite, and also the what we found in Atapupu is also found there, the hornblende diorite and so on. And then this was explained by Linhout and his colleague as the overprinting of the old Tehoru complex, and then combined with the anti-clockwise rotation of the Seram block, and that creates this right lateral shear strike slip, which are not, then later on were explained very well by Jonathan Ponal. So this was more or less similar situation in western part as well as in the Kaibobo areas. You get here more or less a similar Barovian path, but then this is because of the overprinting of the hot ophiolite there. More or less similar situation was also carried out by Monnier and his colleagues from France. So Linhout and his colleagues tried to explain or to reconstruct the paleogeography as well as the closing of the Indonesian seaways there by the discoveries in Seram and Buru areas, in which he concluded that, for example, the position of Buru's Seram here in Miocene areas, in Miocene time, is more or less the situation here. So he proposed the presence of having this left lateral strike slip fault, and then it's followed by the clockwise, anti-clockwise rotation of Buru and Seram that brings into the present position. Of course, this is then open for the discussion, but then my attention or our attention should be and what can be further, substantiated and supported by later on by research on paleoceanographic areas in order to support or to oppose the reconstruction what we have already proposed before. This is you see here the PT path of the peridotite here, and also the underlying metamorphic rocks, showing here more or less similar situation by having the emplacement of the hot ophiolite near the or at the edge of the Weber Deep. So we propose that the hot Weber Deep materials perhaps because of also the slab rollback mechanism proposed by Robert Hall and Jonathan Pownall, that creates the metamorphism of the Seram and Buru areas. So when we are trying to reconcile everything there, then we are actually dealing with at least 2 or 3 tectonic mechanism or environment there. In the south, toward Banda arc, you are dealing with the normal, more or less more frontal arc continent collision with slight break off, as I've already shown before, around the eastern area of Timor, then creating the emergence of the smaller islands here. And then, but then as you go further to the north, then here you are dealing with more extreme extension as well as the right lateral shearing of the Buru and Seram here. So then you are dealing with more or less 2 major tectonic regimes here when we are talking about the Banda arc then. Okay, what will be the implication? Now we go back to 45 million years ago when you still have these tropical areas are more or less still open, then there is no what do we call obstacles here in the Tethys area between the Australia and the Southeast Asia here, and that is why we have a free-flowing deep and cold current from the Pacific into the Indian Ocean. Then in 22 million years ago, Indonesian seaways is starting to becoming close by the northward drifting of Australia, and then you get starting the bouncing of this northern equatorial current here. Then further, as you go further younger, then the bouncing back here is getting more, and as the areas here getting more complex and more islands and deep oceans are smaller oceans, microplates and so on were formed here around the Wallacey areas. And then when we concur or we confirm to what Robert Hall has put here, construct in 13 million years ago, what I'm trying to discuss with you is that whether this reconstruction is supported by, for example, by paleoceanographic evidences later on. This is what we assume as the more warmer current, Pacific current to the Indian Ocean, and this is colder current here flowing through the Makassar Strait. Then we go further younger into 11 million years ago. You get more complex here of the warmer current because this is closer to the equatorial, and this is more colder current here flowing through the Lombok Strait, for example, or the Proto or Old Lombok Strait. And finally here, in the Pliocene time, then we started having, because of the extension and the opening of South Banda Sea and of the North Banda Sea, you get here the bouncing of this Indonesian through flow or the older Proto-Indonesian through flows. Then, okay, I will go further on based on this development. But then before then, I will just give you just 2 provocative ideas, on how, for example, whether there is a possibility of having the pre-tertiary reservoir. This was written I wrote it in 1994, that there is a possibility, for example, in the Saman-Saman limestone in Manusela formation, because of this strike slipping and also the placement of the hot ophiolite, you get some kind of what do we call the stacking of this reservoir, getting the possibility of having more reservoir. I think now I will call all the experts and the oil explorations and so on. But then this is the possibility of having, for example, the hydrocarbon exploration in the previous area. Now for the gold exploration, I mentioned about the hot carbonic fluid, which dilute, the gold element there, because in the past, there was quite intensive. That brings the Dutch, do some exploration in the River Noni. River Noni means in local language it's river of gold. The River Noni is in the in the Myomorpho massive there. And that is why, for example, that may explain, that the ophiolites brings the possibility of having gold. And this was also supported that in West Africa, that gold is present in ophiolite and also metabasalt. So maybe later on, Jeff can talk about this, what is possibility. So this is the final part. Then I will talk about on the oceanographic situation now. That is, there is a verb saying that the ocean's music determine the dance of the climate. So this is the ocean conveyor belt. Yeah, I think the oceanographer mostly know about this. So you have here the continuous warm current here from the Pacific into the Indian Oceans, and then somewhere here in the near the North Pole, it sank because of cold and also the high densities because of the salinity and so on. And then you get here the turning back of the cold current and going upwelling here in the Indian and as well as the other one in Pacific. So this is the continuous, the eternal conveyor belt hypothesis that explains the ocean current. In Indonesian part that you get here, what we call the Indonesian slope flows is quite complex here. You have here a continuous flowing of the cold current from the northern Pacific here, and the warmer current forming here Halmahera eddies and Mindanao eddies here, and then it went here through the Livamatola Strait and so on. And but then you see here part of yeah, it bounced back and then it stays here in the Banda Sea about 50 years, and then it upwells and then goes further through the Ombay Strait as well as through the Timor Sea. So this is the eternal sea because of this situation. And what we found here is the, mostly this 9 sphere drop goes mostly through the Makassar Strait, and then it bounces back through the Banda Sea here. And what is interesting here is that you have here more warmer current through the Matola, and then the tropical whirlpool in normal condition is accumulated here because of the emergence of the Papua islands, and then that creates the normal condition of the Pacific whirlpool. And because of this aborted rifting of the Strait of Makassar and also the blocking of the eastern Nusa Tenggara, that makes all these types of the current of the Indonesian through flows down. But mind you that at least during the last 100 million years ago, you have quite a continuous input of the materials, energies, and species, and so on. That explains why, for example, in watershed areas, the diversity is very rich, especially not only in the on-land diversities, but also in the marine diversities. And this explains you, for example, why you have here the highest amount of coral reef genera here around the islands of Sulawesi, and you can just name it another whatever the species, marine or as well as the terrestrial species there. So in Western Pacific area, you get 3 major phenomena. You have here the monsoon, you have Indonesian through flows, as well as, of course, the crucible current and so on. And then the third one is the what we call the ENSO, the movement of the water mass here to the east because of the warm water mass moving here that creates the El Nino situation. This is the situation, more or less, the 3 major climate agents that regulates the Indonesian climate here. That not only the monsoon, but also the Indian Ocean dipole mode as well as the ENSO. And when both are in positive position, then you get dry condition because of the cold oceans here around Indonesia, and then that creates what do we call extremely dry condition, and I can explain it later on. The same situation. And what is striking here is that in the Makassar Strait, the continuous monitoring here shows you that the current is getting slower here, especially in the depth of the thermocline depth here around this 300 meters. here you have quite a change. That means that explains you why this makes you should worry about that the current from the Pacific Ocean to the Indian Ocean is getting less and less, and this is also supported by the next diagram. You know. Oh, what's wrong? Okay. Yeah, here you see here the continuous monitoring from 2005 to 2016 by instant monitoring shows you here that the water mass here monitored here in the Labani channel here, that the south flowing water mass is getting less and less, you know, while on the other hand the northern flowing water mass here monitored here Labana channel is getting more. That means you get less and less supply of cold water from the Pacific, and this is of course quite threatening, and that is, you know, explain also a moral situation here, that the cooling or the difference in sea temperature here in in Strait of Makassar is much larger than, for example, what is monitored in Omai Strait and here near the Sabu Sea. That means an interesting thing is that when we bring here the monitoring of this water mass, you know, the volume transport here found in Atlantic meridional overturning circulation, they shows more or less similar volume transport. That means the impact of the slowing in the Strait of Makassar in Indonesian sea flows is also give impact also in areas near the North Pole. That is of course quite influential in the future when we are talking about the global climate. So this is the El Nino and Indonesian double mode here, showing you here then the impact of during dry season as well as in the wet season. In the El Nino time, you see here, this is the normal situation, and during the El Nino time, 1997, almost all of Indonesia is extremely dry because of the cooler water mass, sea water in Indonesia. And on the other hand, here in the La Nina time here in 2010, you have more wetter condition in Indonesia. And mind you that the time interval between one El Niños and another one is getting shorter and shorter, you know, especially after the 1981 until recently. You see here formerly from 5 to 7 years, now it's getting more and more closer. That means the anomalous situation experienced, especially in Eastern Indonesia, also is getting more severe. And this is then open for further discussion whether the Eastern Indonesian waters is still, you know, functioning as the sink, you know, because you have here higher increase as we monitored before, but here you have here lower temperature increase in Level Motala and also as well in the Umbai Strait here. So then I will come almost at the latest part of my talk. Then this is you see here the animation of the surface air temperature that gradually is getting warmer and warmer, and of course you can expect naturally here that the areas, for example, near the North Pole as well as in the Himalayan areas and other higher areas also in South Pole is much more getting warmer, and then you can expect then later on you will hear drowning of the Bangladesh and the, you know, South Indian areas, as well as of course the rising of the sea levels because of the thermal expansion as well as the warmer sea surface temperature. And this is the projection made by the, you know, BMKG, that after 2030s, then you have here the Eastern Indonesia is getting more warmer. You see, this is January, February, March, April, May, June, and so on until December. So especially we are in Eastern Indonesia, in the Philippines, the first semester is getting more warmer, but then in the second semester, Eastern Indonesia is getting warmer than normal, in the 2013, while on the rainfall projection here, it's different, and especially in the second semester, you see, Eastern Indonesia is getting wetter as compared, for example, in the first semester. So by having that, then I will conclude this my talk from metamorphism into the global climate, that we still have some question mark which need further research and investigation. For example, on what is the age and origin of the South Banda Sea, and also of course the Northern Banda Sea, and this was of course related with the dynamics of the oceans and the Banda Sea and so on, as well as what will be the origin of the Savu Sea. Whether gold is also present in Ophiolite, I think I leave this to Jeff, and also to Pa Awang Harun and other oil geologists here, whether hydrocarbon is also still possible here, and especially in northern Banda Arc. And finally, the issues of Indonesian seaways, not only be the responsibility of the present oceanographers and so on, but also geologists also, are invited also to, for example, to understand when actually El Nino starts, whether it's in the Pliocene or the recently, and by having this try to find where is the key key location for the paleogeographic reconstruction, what will be the paleoceanographic reconstruction, as well as the paleoclimatic reconstruction. I think by then, thank you very much. I hope that I didn't use much time. Thank you.
Thank you very much, Professor Jan. I am very impressed and very amazing because you spent exactly 50 minutes. I don't know why. How you do that.
Thank you very much.
Wow, incredible. Thank you. Thank you very much.
I was talking like a thief is just chased by the police,
Yeah, I noticed from the beginning, but I was very, very surprised because you spent exactly 15 minutes in my notes. You start 2:30 and then now is 3:20 in Makassar time. So it's exactly 15 minutes. Maybe
thank you very much.
20 seconds or 30 seconds more. Okay, that's all the presentation from Professor Jan. And then I do believe that some and maybe many participants will have some question or eager to know many things related to the tectonic petrology. And then we are talking about global climate as well. And then I am very, very interested in how to relate the tectonic and then the petrology data into a climate and things like that. So please remain, Professor Jan, because after this we will have I think 10 minutes, 5 or 10 minutes. I will give back to the committee because the committee has a special, I think maybe a special event. Okay, maybe I will give it back to the committee, please. And after that, we will continue with Dr. Jeff for another session, another 15-minute sessions about the economic geology. Okay, I will give it back to the committee.
Maluku selama ini kan tertinggal jauh sekali dari Papua, dari mana-mana. Ini akan kita kembalikan biar bisa sejajar dengan provinsi-provinsi lain. Kemiskinan terjadi karena sumber daya alam yang begitu kaya namun tidak terkelola secara maksimal. Visi besar kami adalah Maluku harus terkelola secara jujur, bersih, dan melayani, terjamin dalam kesejahteraan dan berdaulat atas gugusan kepulauan. Ini akan kami berkomitmen untuk bagaimana mensejahterakan masyarakat di seluruh kabupaten kota yang pernah kami sampai dan akan kami kembali. Kami datang bukan untuk melayani.
Kita berharap UMD ini dengan tata kelola yang baik mampu menghasilkan pendapatan yang cukup berkontribusi kepada pendapatan daerah. Tentunya salah satu caranya harus dengan tata kelola yang baik. PT MEA itu punya harapan besar ke depan bagaimana akan menjadi salah satu sumber pendapatan daerah yang akan mensejahterakan tidak hanya di wilayah operasional tapi seluruh wilayah Maluku.
PSKK Migas juga mendorong keterlibatan SDM lokal baik saat fase pembangunan maupun saat proyek operasional Blok Masela. Hal tersebut agar masyarakat Maluku merasakan dampak positif keberadaan proyek Blok Masela.
Oke, saya kira kita, I think we will continue our session into our second distinguished speaker, Dr. Jeff. I just want to check, Dr. Jeff, are you with us?
Yes, I am. Can you hear me?
Yes, I can hear you very clear. Okay, Dr. Jeff, you have 15 minutes to share your presentations. And after that, we will have a discussion. And then I hope that Professor Jan and you can also join. And then we will have some questions from the audience. Okay, Dr. Jeff, time is yours now.
Thank you, Prof. Adi. Let me share my screen now. Right, can you see my screen?
Yes, you can. Yes, go ahead, please.
Good. Thank you, Prof. Adi. Good afternoon, everyone. Good morning from here in London. From my short curriculum vitae read earlier today, I think you can gather the last 21 years, I am no longer a pure geologist. I work in an investment bank as a mining analyst. That's to look at mining projects, whether they are capable of support, for financial support from various companies, and therefore today I'm going to talk something completely different. That's investment side of the mining industry. So I'm talking about the business perspective of mining industry. What is mining investment? What is the process and the risks and the reward in the mining business? I hope with this talk I can give a bit of context for the exploration geologists out there, so they can understand why certain decisions are made, and also for some of the non-exploration geologists, the academic geologists, you can also hopefully can learn a little bit about the mining industry. So let me start with why do we want to become a geologist? This is a slide from a schoolboy, age 7, or age 9 actually. If you read that, I won't read it all, but some of them we can pick up is personal saving, so money, obviously, it's something that people are interested in. Travel, that's a good reason for a lot of us to become a geologist. Looking at scientific curiosity, in this particular person looking at volcanoes. And then also a lot of us, particularly me, I like to talk to local people, learn about different culture, and of course, lifestyle. So I think these are all very good reasons to become a geologist, and I'm happy to report that this particular boy is now a very successful exploration geologist in oil and gas business. But in reality, the role of geologists changed a lot. As an exploration geologist, our main job obviously is still technical. Our task is to find oil or gold or copper or whatever it is that we're looking for in a cost-efficient way and quickest way of doing it, and to give enough confidence for the mining engineer or the petroleum engineer to exploit those resources. But also, I think for a lot of exploration geologists, it is very important to know when to stop. If I always say, don't fall in love with your project. Don't keep chasing things when it's not there, because at one point, you have to say, okay, it's not there, or it's not economic. So you need to know when to stop, and that is actually a very, very important part of the job as well. But outside of technical stuff, we are now as a geologist, we have to deal with a lot of other things. We have to deal with logistics. We have to deal with local workforce. In many places, you have to deal with local communities, so indigenous people, either Aboriginal or First Nation in Canada, even local people, local cultures in different parts of Indonesia. Of course, we need to be able to do management, create budget, reconcile the budget. We have to talk to suppliers, the drillers, the geophysical consultant, geochemical consultant, etc. But also nowadays, we need to start talking to investors and regulatory bodies, like the stock market. We need to, sometimes we have to present technical stuff to your investors and to journalists. So our jobs now become multidisciplinary and multitasking. And this is something that's, I think with modern time, we need to start recognizing that. When you look at this list of people that we talk to, most of them aren't geologists. In fact, probably all of them aren't geologists. So we need to translate our work program. We need to translate our results to non-geologists. So communication skill is extremely important, and I'll talk about that a little bit more in a minute. And hopefully by the end of this talk, we can give impression to everybody here that this industry is not only global, but it is extremely high risk, and there's a long time between exploration to mining. So it's something to keep that in mind. Successful, I think it's not only technical, but you also need to have the support of management, the support of a board of the company, and those support has to be balanced between technical, legal, financial, and marketing. That's another important part of this now, that we need to talk about marketing. So why do we do that? Now a little bit more later on about the risks and reward factor in investment is what's called fear and greed. So we still need exploration. I think the short answer is yes. I mean, I'll take this slide from two different slides. One is from 2011, so 10 years ago, and this is from 2020, so it's now only a year ago. I know it's not quite the same. This one is world citizen, this one is American only, but you can see there's still, for each person born, we need in 2010 or sorry, 2011, almost 3 million pounds of material throughout his lifetime. And in 2020, for every American, it's over 3 million pounds. That's a lot of material for every single person. And you can also see that the various commodities change throughout time. So in 10 years ago, we're needing a lot more coal. We probably need about half of that now. And it's the same with bauxite. It's lower in bauxite, but other materials start increasing. So as the world change, the various commodity change that we need, but we still need a lot of commodity. And of course, what happened is the world is not only rising in population, but each one of us are increasing in wealth and lifestyle. And recycling can only count for some of our need. I mean, I just gave you an example. 10 years ago, you probably have one mobile phone and maybe one laptop. Now, everybody in your household probably have mobile phones and everybody probably have a laptop. So, imagine that, multiply that by billions of people. So that amount of need for mobile phones, for laptops, etc. It's all going to just increase. And therefore, we still need exploration. We still need stuff to find. In the world is, I don't need to tell you that everything in the world is grown or mined. So yeah, we need resources. Like I said, our job as exploration geologists is to look for these commodities. Now, these commodities, whether it's gold, copper, zinc, oil, or gas, they can occur just everywhere in the world. I mean, if you can look at the top diagram there, that's some distribution of ferrous material, and they basically occur everywhere in the world. We cannot change where they occur because that's obviously related to the geology of that particular area. But what it is that you can find those commodities in any country, a lot of countries in the world. So for instance, if you're looking for gold, you don't have to look for gold only in Indonesia. You can look for gold in South Africa, in Peru, in Canada, Australia, etc. It's the same with copper and oil and gas, etc. So it's very, very rare for a particular commodity to be just in one country. Most commodities occur in various places in the world. Why do I mention this? Because there's problem with resource nationalism. Some people say, oh, Indonesia is rich in gold or rich in oil. In reality is that Indonesia, in any country in the world, is competing with everywhere in the world. Now, I'll give you an example. The bottom diagram is the amount of exploration budget in 4 years ago, 2017, everywhere in the world. Now, if you look at where it is spent, most money spent is Australia, Canada, and USA. All are mature countries in terms of exploration, and therefore those countries, you think, you need to be clever. You need to find more difficult deposits which are hidden. The ones that sort of sitting on top, on the surface, no longer there. But you can look at that. Australia, Canada, and USA. There's a lot of resources. Europe's got a lot of resources. It's only got 5, relatively speaking, small amount of money. Central Africa and Southern Africa, again, a lot of resources. Relatively speaking, a small amount of money. India has got a lot of resources. Almost no exploration. Same with Southeast Asia, Indonesia, Philippines. Relatively speaking, small amount of money. Russia, it is the largest country in the world in land size. little exploration. So what the point I'm trying to make is that your global industry now. So people will go where the rules, the regulation, the political stability, and the investment climate are there to support your investment. Let me go on. So, I like this diagram because it explains what is exploration to the general public. It is a bit like this is, I think, a story from India where different people look at different parts of an elephant and just say, okay, the tail. If you just feel the tail is like a rope, if you feel the ears like a fan, etc. But to me, this is a bit like exploration. So if you look at geophysical anomaly, it's probably just like the noise, like a thunder. It could be anything. You can see geophysical anomaly could be gold, copper, etc. You see a bit of geochemical anomalies, probably looking at like the lack of something. You don't know what it is. It's interesting. There's elevated gold, elevated copper, etc. But you don't know how big it is, etc. Look at the tails, probably looking at geological anomaly, etc. So what I'm trying to impress here is that I've seen reports, particularly a lot of reports from Indonesia, where people look at just a geophysical anomaly and start calling it a resource or even reserve and start making it into this is how big it is. Well, you can't do that because you don't know what it is based on just one anomaly. Exploration is when you combine all these anomalies and then you start drilling and then you define the body of the material that you want to exploit or explore and then eventually exploit. So let me go through some of the processes, the processes in the mining industry. So the first one, of course, is to identify an area and acquire title, acquire the right to explore and then eventually exploit that area. And that can take 1 to 2 years. And I think this is quite optimistic time scale, 1 to 2 years. I think in reality, it's probably taking longer. And then after that, you going through exploration, your discovery, and then you go through resource definition. You define how big the body is, etc. That will take 5 to 10 years. And then you have to go through feasibility study, changing that resource into reserve. And then on the back of that, you do the financing. That takes 1 to 2 years. And then after that, you go through the construction of the mine, depending on how big the mine is, but that's 1 to 3 years. If you just added that, between that and this, that can go up to about 20 years. And then you've got exploration, production and operation and production of 10 to 30 years. And then again, depends on the size, obviously. And then you go through mine closure, which is 1 to 2 years, 1 to 4 years of rehabilitation, and then the cycle goes round again. Now, each step of this is extremely costly. And if you look at it from the first 20 years, i.e. between your identification all the way to development and construction, you don't actually have any income. It's all spending money with no income. So in order to support that, you need to either get your support from the stock market, or in the case of bigger companies, from production project that you're producing. So, you have to keep that in mind, that you're spending 20 years of, you're spending a lot of money, millions and millions of dollars for 20 years with nothing to come back to for your investor. And then at the same time, throughout all this 20 years old, all the way to 30, 40 years, you're dealing with various risks, and I'll go through the risks in a minute. But the main thing, of course, is geological. Is the deposit there? Is it economic? How big is it? How deep is it? That's all I would call that geological risk. And then you've got financial risks. Can you fund the project? The market can change. The price of the commodity change. All of a sudden, stuff that are needed, no longer needed. Things the world's a dynamic place, and you're looking at 20 years time scale, and yet the world moves at a much faster pace. And then, of course, you've got the political problems as well, the political risk where countries change government, change rules, etc. And what it means is that most of the project is a failed project. I would say more than 90% of projects, mining projects that you identify will not make it into exploitation, will fail. So it is a very, very high risk project, high risk investment. And we as geologists, and I know sometimes you have to talk to the local people, and we end up having to talk about CSR projects, community social responsibility, corporate social responsibility program. We have to be careful with that, because we don't even know whether this project, any project that we're working on, will be there for the next year or 2 years. So you need to manage that expectation of the local people. You can't promise, for instance, that you will build a hospital when you don't know whether you will be there in the next 2 or 3 years. So it's, I'm always emphasize that to my people, we manage expectation. More about uncertainties. Now, as I said, the projects that you're looking at will take 10, 20 years before you get into production. So that's a long time to be spending a lot of money with no income coming back. So what you need is stability. You need some sort of certainty that your investment will come back. Whatever money you spend, you'll eventually reap the reward. And yet you're faced with not only geological risks and commodity risks, but you're looking at various other risks as well. For instance, as I said, most of the projects you need to depend on the stock market, and that depends on the global investment climate. The last 10 to 15 years, people are becoming more risk adverse. So you don't know, if you have production, you can get financial support from the stock market, but your exploration, it's very difficult unless it's a particular commodity. And those particular commodities, for instance, people looking at lithium, that is seasonal. In the next few months, few years, maybe lithium is, you can fund it, but after that, things change. Political stability, I mentioned this already. There's examples of mines, Bougainville in Papua New Guinea, which is an operating mine, had to close because of political stability. I'm involved with one of the best gold projects I've seen early stage in South Sudan, but then all of a sudden there's a civil war, so we have to call force majeure and close it, or not close it, suspend it. And then you deal, I know a lot of projects that stop because of community relation problems or labor unrest problems. For instance, in this picture in South Africa, where you got labor unrest. Changing of rules, that makes a lot of difference. I'll give you an example in Indonesia, in Orde Baru era, where we have contract of works, OW system, which is one of the best for mining investment, one of the best system in the world. During that time, I would say most, if not all of the mines in Indonesia were discovered during those time. And then we changed to different rules now, and there's less and less mining investment now in Indonesia. Certainly very little junior companies, small companies. What's still in Indonesia are the bigger companies that's got the production to support their exploration. Changing of global commodity price, I use an example there, for instance, Masela in Maluku, where the price of gas changed, and then it makes it more difficult now because of the drop in price. You've got uncertainties within the management of the company and corporate changes. I've seen, I used to work in East Java, for instance. We were partners with Anglo America, which is probably the second or third largest mining company in the world. they change direction. All of a sudden, they pull all the exploration. Only, I think at one point, they only have like 3 or 4 countries in the world that they're exploring. So that will affect your project, obviously. And then more recently, COVID, that has effect on exploration. A lot of people stop exploration because of that. In Africa, also Ebola and various other illnesses that will have effect on your project. And like I say, this is I have to emphasize this. There's a time lag. There's 20 years of exploration before you get into production. And that's something that is there. You can introduce a lot of uncertainties in that time. But why do you do that? Why do people still do that? Because of fear and greed, because of risk and reward, and it's tend to swing. If there's, for instance, political instability in one area, people get fearful, and then all of a sudden people pull out all the investment in that area. But if there's a success in one area, people get greedy, and then all the investment money gets into that area. So, like I said, there's one point, for instance, people were making a lot of money from graphite, and then all of a sudden, all the graphite projects get funded because there's greed coming, and then there's problems in one country, in South Africa. Everybody pull out of South Africa. So it's the fear factor, and it swings. So let me go through some of the value profile in mining project. And like I said, if you look at the time scale, that this is more optimistic, I would say. In reality, probably takes double the time. So you start with identifying and acquiring title, and there's very little value there at that time. And then you start doing exploration, and if you're lucky, you find something, and then of course the value of the company goes up, and then gets to a point where you start seeing how big it is, and then of course if it's very big, then that value goes up higher and higher. At one point, you have to stop your exploration and then start doing what's called feasibility drilling. So changing your resource into reserves. And that's actually when most likely your resource will drop. Instead of 100 million ton, you end up with 80 million ton or whatever it is. Yeah. So that's when and it's expensive, because you do reserve drilling. So you're doing drilling at close space. So you spend a lot of money, you're reducing your resource and changing it into reserve. And after 2 years or so, what you end up is a bill for capex, for capital expenditure of hundreds of millions or maybe even $1 billion. So the value of your project will drop during that time. And then, of course, you start construction, which is again 1 to 2 years, 3 years of development and construction. Your value will start going up when you start producing. That's when you start receiving money. And of course, you start slow normally, and then you ramp up your production. And at one point, you hit your maximum production. And then your production's mature, it's more or less stable until the end of your production. And then if you don't find anything, that will drop off very quickly. But if you find something during that time, then you go into the next cycle. As you see from this, your biggest value creation is finding something in your discovery point and in your production point. And of course, the third thing is when your commodity price goes up. So there's a similar graphic, but a lower scale if it's a local commodity. So how do companies manage this curve, this risk? It's by diversification. So in an ideal world, when you have 2 or 3 different projects, so that when one project is going through feasibility, you've got another project that hopefully can drive your value by having a discovery. You also have not only different project, different stages, but in a bigger company, different countries, different commodities, so that you can balance all of that. The issue is with bigger companies, your most of the value is actually up in that curve, in your production curve. In other words, if you're a Rio Tinto, Anglo-American, or some of these other large Billiton, some of these large companies, your discovery will not have any effect on your share price, because your share price will be determined by your by that production and by your income. So your commodity price will have more effect than your discovery. Whereas if you're smaller companies, people in this industry, people call it junior companies, where you're looking at just one or two projects, your discovery will have a huge impact on your value. And of course, your production will have a big impact on your value. I also want to say something about exploration and market expectation timescale. As I mentioned, you're looking at this alone is probably 8 years. In reality, it's probably you can double that. Now, imagine if you're an investor, you're putting 10 million rupiah into the stock market, or whatever it is you want to put into the stock market. Would you want to wait 8 years? I wouldn't. I wouldn't wait 8 years. You probably want to get something out of it in 2 years. So that is critical. There's a big difference between your time scale on exploration and putting it into production with your time scale of your investment. So as a company, you need to get more excitement. You need to move extremely fast to try to reduce that time scale. Also, I think I already mentioned about resource and reserve, but one thing I want to mention is the grade. Again, generally speaking, the higher the grade, the smaller the project will become, and therefore smaller your capital expenditure at the end of the day. So grade, and there's a saying in the mining industry, grade is king. So if you get good grades, go for it. If you have a lower grade, then obviously potentially it's more difficult. You're more prone to the commodity price change. As a commodity price drop, then your low grade deposit potentially could be non-economic anymore. So I'll give you an example of just one project I'm involved with, which I would say sort of just sitting at the edge of discovery. So this is a project that I'm involved with in Canada, in Ontario. It's a copper zinc project. The project was drilled in 1970. It's a small project. It's got only 2.2 million tons. Decent grade, 1.3% copper, 4.2% zinc. Like I said, this is in 1970s, and for about 30 years, nothing happened to the project. There's various people who own it, drill a little bit, these sort of various drill that people do, and nobody hit anything. So it's people didn't really take notice of it. In about early 2000, somebody has this project, run out of money, joint venture it with somebody else, run out of money, joint venture it with the third person. So by about 10 years ago, you've got the same one project, ownerships, three companies, all roughly owning a third. So it is very difficult for anybody to get interested in this project because the ownership of the project is broken. So we got involved. We now consolidate this project so that 80%, 86% of it is owned by one company. We consolidate all the work before. And like I said, this is in Canada, so there's a lot of work. There's a lot of geochemical work. There's a lot of geophysical work. But finally, what we did is we shoot some RP exploration survey at depth, and what come out is that there's a great big IP anomaly sitting there, and there's 3 smaller ones sort of sitting sort of parallel to that area. Now this is what's called a volcanogenic massive sulfide deposit. So VMS deposit is normally occur in clusters. So that fits in with the model. Ideally, if one is economic, potentially the other ones could be economic as well. So we're now in the process of going to drill it. Hopefully in the next few weeks we can start drilling it. Now it is exciting, it's very exciting, but we still don't know whether this is all pyrite or whether this is maybe only 0.5% copper, or maybe only 0.5% zinc. We don't know until we drill it. So like I said, it's exciting, but it's also, there's a huge risk of the whole thing failing. If it's non-economic, then we probably have to walk away from this. We don't know, or unless we find something else in this area. So this is where I say that it's exciting, and this is where it's, although it's 90% chance of failure, but the 10% of success will cover your 90% of failure. So, as I say, how do we fund all these projects? You got 20 years of no income. The obvious place to fund it is from the stock market, and there's several stock markets in the world that can fund projects. In Australia, the Australian stock market, in Canada, Toronto Stock Exchange, and also in London, it's called the AIM market. Those are sort of traditional places to fund exploration projects. And I won't get too much detail into it, but if anybody's interested in those stock markets and how they operate, I'm more than happy to talk about it. There's also different ways of funding it. You can go through what's called equity. In other words, you sell your shares and get new investor coming in, or you can go through corporate debt and various things. Again, I won't get into it in this talk. I think what I want to get into, emphasize here, is communication. We are geologists. We got all sort of interesting geological results, but when you talk, there's no point in talking about dextral transpressional brittle shear zone to your investor. He or she won't be interested whatsoever. What they'll be interested is, how is it going to make money? Now, if I put in $1 million now, when can I get more money coming out of it? And how much more I get out of it? That's sort of thing that you need to translate your work, your technical work, into something that people can understand. One other thing I want to mention, well, on this slide, is the people often hear of JORC, or GORC standard. In Canada, it's called 43101. In South Africa, somewhere. Those are standards, so that when you present your exploration work, or even your resource or your reserve eventually, there's a standard. There's everybody knows that if you're at GORC, then you've done your sampling properly, you've done your drilling properly, you've done your testing properly, etc. So it is, the way I mention this to our investor, is it's like having an audit. If you got a financial results, any company with a financial result, you have to audit it. An independent auditor will say, yeah, that's a good, all the results are good. Or JORC or 43101 is that in the technical sense. It's an independent body will come and say, yeah, you've done all your work properly. So you need that when you want to do your, when you want to list in the stock exchange, or when you want to go to the bank to borrow money. But if you're doing it all for yourself, then as long as you've got confidence, then you don't really need it, in a sense, because it's all whether you believe your results or not. So I've sounds a bit negative, 90% failure rate, long lead time. So why do we do that? Because of this fear and greed. As I said before, you got 90% failure, but the 10% failure will make you maybe 50 times your money in that exploration, in that discovery curve. So that's why people do this. And of course, we need exploration. We need, we can't live without exploration because the world's still expanding. And I think, I believe our work, mining industry, make a huge difference in human life. There is Petrol Earth, which is basically run by the mining and oil and gas industry. And in Canada, minerals and oil and gas, it's a huge part of the economy. Norway, oil and gas, a huge part of the economy. Great Britain in 1970s, that's the discovery of North Sea oil. That makes a huge difference in the economy of Great Britain. You all know about Middle East countries, which is now all driven by oil and gas, and of course South Africa. We do have to acknowledge that whatever we do will have a footprint. I mean, that picture there is a city called Kalgoorlie in Western Australia. It's a city literally next to one of the largest open mine pits in the world, the super pit. And that's gold mine. So we will have a footprint. We will have impact on the environment. I think that the thing is how do we minimize that impact and get benefit to the people. And of course, mining is not renewable, so we need to think how to use the proceeds of this industry to have a sustainable life. I mean, we know Middle East, for instance, they've invested a lot of the oil and gas profit into airlines, tourism, etc. Norway's got one of the largest state sovereign fund in the world. So they use that money from oil and gas to invest in different other industries in the world. So, talking about minimizing impact, I want to talk a little bit about the roles of civil society and communities. I mean, this picture, unfortunately, is in Maluku. It's in Bulu Island, where you've got a lot of small miners with very little regulation, creating a lot of problems. What I want to talk a little bit here is the fact that there's a difference between listed company and local or artisanal miners. Listed company particularly, you've got not only the stock market regulating you, but also your shareholders. So if you're doing things wrong, your shareholders can very easily kick you out. And this is an example of, this is a year ago, the CEO of Rio Tinto and the two top executives of Rio Tinto were forced to quit, to resign, because they've done, they blow up indigenous site in Australia, in Western Australia. So your shareholder and civil society can have huge impact. And I think it's good to have those input, as long as there's also balance. You need to realize that we're not all bad people in the mining industry. We're trying to do good things as well, but it's a balance. I just want to finish this with Maluku. I think they all talk. People talk in the last 3 days about how complex and geologically interesting Maluku is. It's got active tectonic process, and of course, it's got huge potential for oil and gas. The Malaihollo project in Southwest Maluku is one of them, of course, and in North Seram as well, in Bula. That's only two that we know. There's probably other potential still in Maluku. And then you've got gold in Wetar, copper in Wetar, zinc, and potentially nickel. So it can be a huge benefit, but we need to manage it properly. On that, I will stop my presentation.
Thank you, Dr. Jeff. for very, very inspiring presentations. Okay, ladies and gentlemen, all participants, now I will open time for discussion, and then I will divide into two sessions. The first session, I will invite three questions or maybe three comments. And then the other one, we will see the time. If we still have plenty of time, we will open another session for discussion. Okay. Okay. I will read. I think there is some questions in the chat room. The first one, okay. The first one is from Dr. Chef to Professor Jan. Okay, increased occurrences of El Nino and La Nina, how much is due to human activities and how much due to geological factor? I think this is a question for Professor Yan. Maybe Professor Yan, maybe you want to answer this question first?
Yeah, thank you, Jeff, for the questions. Yes, El Nino is actually a natural phenomenon that because of this blocking or diversion of this formerly was a free-flowing, warm equatorial current, and then because of this northward drifting Australian continent, then is also coupled by the emergence of islands, dispersions of these microcontinents, as well also the new basins, North Banda Basin, South Banda Basin was formed. And that makes, this formerly free-flowing warm equatorial current was then changed, and especially because of this emergence of the Papua Islands, and that makes, in the normal condition, you have this, what we call the tropical warm pool, just north of the Papua, And then because of these dynamics of the ocean, as well as also the changing in the wind forces, that makes, this warm, we don't know exactly because, research is still going on about this El Nino, the dynamics and the origin, especially the dynamics, the warm water mass, moves, to the east, and that creates, so-called El Nino. Of course, you can read it many in the internet and also the existing publications. But then with the warming climate, this can accelerate also and also form or accentuate, the forming of what the scientists normally calls this super El Nino, in which the super El Nino is defined that not only the length also, but also, the warm water mass, not only situated or driven to the east, but also it gets west, it moves west, even 1,000 kilometers to the west. That means, the evaporations, also the dry climate, also, as well as you see gently also in Australia, while in the eastern part of the Pacific you get more wetter, and also to the north of this Capricorn tropics, you get this more typhoon and hurricanes and so on. It's getting more and more, So that is, I think, this because of this impact of the warming climate that makes, the distance between one El Nino and the other El Nino is getting closer and closer. And normally after the super El Nino, normally the following year is followed by the La Nina. This is happen, but it's not always, but then normally that can happen. So to my opinion, the geological control is only influencing to the initial development of El Nino because of the blocking of this rising Papua. Also the Halmahera is coming in there, also the North Banda Arc, Southern Banda Arc, that creates some kind of more earthquake and complications of this formerly simple Indonesian through flows. But then after that, climate change, warming climate, global warming may makes this El Nino becoming worsen and also getting shorter and shorter distance. I think this is my, my intuition, a guesstimate, not as a climate scientist, but that just by my knowledge. Thank you.
Okay, thank you, Professor Jan. Yeah, it was a very nice intuition actually. Yeah, I like that. Okay, the second questions I would like to go to Dr. Jeff. So it's a bit like a switch. Okay, Dr. Jeff, we have a question from Professor Jan. Climate change is reshaping the evolutions and intensity of El Nino, events in a way that favors the occurrence of more super El Nino. Since the 1970s, there has been a westward shift by up to thousands of miles in where in the Pacific Ocean El Nino is originating and peaking in intensity, as well as a boost in the odds of extremely strong El Nino events. Climate change is then very clear related to human activities. Geological is my opinion because the closure of Indonesian seaway, which makes the free-flowing warm equatorial current was blocked and diverted by the emerging island and small basin. So the big question is that when El Nino, as we understood now, really started.
Yeah, that is what I urge, geologists also to take part in, to check on the sediments, especially in the critical areas in the island where it emerges, also to see the old sediments at the bottom of the seas, to see, the bioindicator of warm climates as well as, cooler climate. So then you can see the stratification from there. You can reconstruct, the paleoceanography as well as also the paleogeography. So, and then you can support or against, what has been already reconstructed, for example, by Robert Hall or whoever, because the reconstruction is mostly based on tectonics and paleomagnetics and so on, but I think it's very little from the sedimentological point of view. So I think paleoenvironmental reconstructions, sedimentary and so on, I think is quite crucial to see whether the El Nino is getting stronger and stronger, in the past by natural processes. So now the question is that where to find, that critical location to see the killing, so that you will have to combine onshore and also offshore as well as seagoing research. This is quite a big task, and this is of the interest of the global community, not only for the Indonesian, also even not only for the Moluccans or whatever. So I think this is the big challenge, and we will have to create this large program, so maybe Jeff or whoever, here can, try to mobilize, the network. Of course, Robert Hall also, who knows that, So what I mean is that we will have to make a greater resolutions of these changes, in terms of the maybe 1 million year or maybe 100,000 years and so on, paleoclimate, paleoenvironment, paleoceanography. I think this is the key, and that determines, the future of humankind, whether it's really, El Nino is accelerated or is getting worsened by the global warming. So this is also a fundamental question, because my answer is just, it can be suspicious, but then it has to be proven. So I think this is the next challenge for humankind and for us also, especially, as far as Indonesia, Eastern Indonesia is concerned.
Okay, thank you, Professor Jan. Yeah, Dr. Jeff, it's very short question from Pak Kumarajaya. So in your presentations, you write about fear and greed. So how do you cope with environmentalists? In most cases, they are against with the project. It's very.
That's a short question, but it's a tough one to answer.
Yes, you're right.
But I think of my experience of working various places in the world, you need to try to engage them. You need to try to talk to them. Some environmentalists aren't open to ideas, and some are more open to ideas. So I think if those aren't open to communication, then there's nothing you can do, but in a sense, but if we are open to communication, then we can build together, we can actually work together, because I do appreciate some input from environmentalists. But also, I think we need to talk about media as well, because I've seen reports from the media where it's just one-sided, where the mining companies get attacked all the time, when in fact there's, on the other side, you've got mining companies in Australia and Canada who are doing a lot of good stuff. In a lot of good, you can develop the country, develop the region, become the motor for change in that particular region. So we need to put our point of view across as well. And again, we need to engage the local community to talk about that. Yes, we are here potentially, could be long term, but could be short term, depends on the success of the exploration. But if it's a long term, we could make a lot of difference to that area. We could actually create, a economic drive for that area. So yeah, short answer is try to talk to them, but depends on which sort of environmentalists they are. I hope that answers the question.
Okay, thank you, Pak Jeff. Yeah, another question for Pak Jeff. So this is a question from Lahuna PC. So how can we quantify or make a value and can measure the risk of geological tectonic and geothermal setting in our mine design, especially if we are about to mine in Ambon and Lis Island, just for geological site example? Thank you. So can you deal with these questions?
Yes, yes, definitely. As I mentioned before, before you get it into production, you need to do a bankable feasibility study, because at the end of it, you need to look for your capital expenditure. Could be smallest one is 10 million, or maybe 20 to 30 million, could be up to $1 billion. So during that time, you need to have the assessment of your seismic risk, your geotechnical risk, your wall stability, if it's an open pit, if it's underground, how stable your underground material is, your water balance, you have ponds, you have tailing ponds, all of that you need to deal with, because nobody's going to give you $100 million or $1 billion loan when that project's not going to be, it's going to be a problem in the project. So all of that will need to, you need to deal with. But in exploration, during that time, you need to prepare all of that work. For instance, during exploration, you need to get database of your animals, your plants in there. So when there's at the end of the project, you can try to restore it as closely as possible to the original. You need to learn about how stable when you're drilling. Not only you're drilling for resource, but you're also drilling for geotechnical. You need to know early whether the pit, if it's an open pit, whether the pit wall will be stable or not. Because if it's not stable, that could actually kill your project. So why do you spend millions of dollars and knowing that it's not going to make it because the wall is too unstable? all of that we'll have to answer. I think that's Dr. Willem's Lohana Pessy's question. You need to get all that information, and then at the end of it, you need to have that assessment all independently assessed. Yeah, so it has to be independent by a consultant. We've got lots of consultants out there, SRPs, let's say, etc.
Okay, thank you, Jeff. Yeah,
Yeah.
I think that's a very good answer. Okay, I think we still have a question for Professor Jan. Prof. Jan, is a question from Pak Roni. How was the impact of the megatrust earthquake in the Banda slab rollback zone or slab brick off in the south? So it can reach the seabed in the front of deformation area and trigger a large tsunami. How severe are the shifts and boundaries in the deformation zone and the temperature value in that area? Okay, Prof. Please.
Yeah. So far we don't know much about the paleo tsunami or paleo earthquake history in that particular area, as well as also in the north. So it's different. For example, with the ones in West Sumatra, along the western coast of Sumatra. Also, now research is now ongoing to unravel the paleo tsunami along the southern coast of Java, for example. If we can do some kind of paleo tsunami research, on the islands on the South Banda as well as in the northern Banda, so then from there we can reconstruct the possible past big earthquake or tsunamis, from the tsunami sediments, aside from, for example, the one which was reconstructed by Ron Harris, for example, from the past tsunami that was possibly from the near Tanimbar there or near Ambon. That was, the possibilities of reconstructing based on, the past model from the data from old data from Richmond, for example. But I think, but for sure, the hazard is there. So when the tsunami-genic earthquake, happens in the south, it takes you more or less, 2 hours, something like that, to reach Ambon, and the other way around, So that is why when we talk about this, one of the possibility to protect, the people at risk on the coast, is, for example, not only from by using this tsunami warning system by the earthquake event, but also we can put there, use the, a simple sea level gauge, along the islands, or the tsunami buoys, not far from the source, because now it is now almost ready or available in the market, that this tsunami buoy, which can be put near the source, but still in the experimental site. But mind you that putting or installing the tsunami buoy is expensive things, So, and also not only installing, but also the maintenance and so on. So then now it is now under discussion in the BMKG as well as BNPB and in the community, tsunami community, is how can we implement or install, low-cost tsunami warning systems in a way that because tsunami is a low frequent but high impact event. So then, meaning that the investment that we put for the warning system should be, cost effective. That is the thing. I hope this answer the questions.
Okay, thank you for Jan. Okay, I think this is because we're really running out of time. I think this is our last questions for Dr. Jeff. Domestic sentiment towards the international investor are so huge in the country like Indonesia. Wow. Can you share with us, Pak Jeff, the real capacity of Indonesian people to do big mining project?
Thank you, Prof. Hadi.
Yeah.
Two things to answer to that. One is, I hope I impressed to you the fact that this industry is global. So there is resource nationalism. People want to develop and own it yourself, which is all fine. But also remember that mining companies, oil companies, they don't have to invest in Indonesia. They can go anywhere else in the world. So that's something to bear in mind. But in terms of capacity of people, one of the good things about the last, I would say, since 1980s, 1990s, there's a lot of mines that have been developed in Indonesia and a lot of people being trained. So we've got a lot of very good geologists. We've got a lot of very good mining engineers. I myself, I use Indonesian geologists in my projects in China as expats. So we know they're capable, and then they can write good reports in English, etc. So it's all we've got the capacity. I think if there's any lack of capacities, probably on underground mining, because we don't have a lot of underground mines in Indonesia, apart from Freeport, in maybe Lebong Tandai. There's few, but not. We've got more expertise in open pit mining. So I think that's probably one area that's less. We have less experts, but the thing I want to say is, because it's a global industry, we can hire people. Now, I've used in my projects like I said, in China, I've got Indonesian geologists. In my project in Tanzania, I've got South African, I've got British geologists, mining engineers, etc. So you can hire people. You can have no national company owning resource, but hire the expertise. And in fact, I should say, we should hire the best people, regardless of nationality, because it's a global industry. We can't, we have to think globally on this. So yes, you can. There's enough people. There's enough good people in Indonesia to do projects. So if there isn't, get somebody.
Okay, thank you, Dr. Jeff. It was a very nice answer, I think. Well, as I said before, I think I am very sorry because according to my notes that we don't have more time from the committee. So let me make some very simple wrap up based on our discussions today. First, Professor Jan Sopaheluwakan. So Professor Jan has already given us very important information. As we know that Banda area is one of the most complicated area in terms of geology in the world. And then this area has been witness or subject for development of earth science and technology. So we know that from tectonic plate theory and then seismic demography and then super plume. So as we have seen from Professor Jan's slides, that we see that the developments of the earth science and technology application in order to reveal the geological phenomena in Banda area. And then from petrology point of view, the occurrences of theolite, of course, has a very significant and very important role in unraveling the petroleum prospect and our mineral occurrences. And then Banda area also play a very significant role in a global climate anomaly until disaster. And then, of course, still many topics that we should study and address to unravel the big mystery in Banda area. And then Dr. Jeff has already made a very nice presentations and very informative presentations. He mentioned that we are now changing the role of exploration geologists. And then, we are in what we call uncertainty risks. And then he also explained about how politics condition in one country can influence the exploration activity, for example, in Indonesia. And then he emphasized also the importance of communications in explorations. And then mining business needs high investment and a very long process. So no shortcut at all. Dr. Jeff also explained the importance of communication. We need to translate technical word so everybody can understand and willing to invest. And then mining will have footprint on the environment, and then we need to minimize the impact. And then yes, Maluku, one of the most complex geology in the world, and yeah, and then we still have so many opportunities to find the energy and mineral resources in this area. So that's all from my notes based on our two prominent presenters today. So I would like to close my session, and then before I handle my sessions to the MC, again, I would like to say thank you very much to Professor Jan Sopaheluwakan and Dr. Jeff for your inspiring presentations, and then I learned a lot from both of you. Thank you very much once again, and then I handle to master ceremony.
Thank you, Mr. Prof. Adi Maulana. Well, ladies and gentlemen, we would like to thank to all of you, especially for our speakers today, Mr. Prof. Jan Sopaheluwakan, the Coordinator of Environmental Disaster for Sustainable Earth and Resources, Mr. Dr. Jeffrey Malaihollo, the Chairman of Edenfield Energy PLC, Mr. Erlangga Septama, PhD, Vice President of IAGI, Mr. Hervin Samalu STMeng, Dr. Candidate from Gadjah Mada University, and also the Chairman of IAGI Maluku, Mr. Prof. Adi Maulana, Professor of Geological Engineering at Hasanuddin University. So, ladies and gentlemen, before we end this event, I will guide us to take a picture together. So, for the participants, please turn on your camera. All participants, please turn on your camera. We will take the picture together. Okay. One, two, three. You can guys thumbs up maybe. Okay, one, two, three. Okay, well, ladies and gentlemen, finally our webinar for today is finished. Hopefully this webinar will be used for all of us. I and the webinar committee humbly apologize if there are any wrong during the webinars. Thank you for joining us, and I see you at another webinar event. For more information about our webinar, you guys can follow us on Instagram or Facebook at IAGI Maluku, and you can also check our amazing webinar videos on YouTube, IAGI Maluku _Tomamaju. Wassalamualaikum warahmatullahi wabarakatuh. Thank you.
Waalaikumsalam warahmatullahi wabarakatuh.
Thank you.
Okay, thank you,
everyone.
Prof.
Thank you, Pak Jeff.
Prof.
Thank
Yan,
you.
Prof. Adi,
Dr. Jeff, thank you.
Anda,
Hope to
Prof.
see you again.
Thank you, Pak Awang.
See you next
Selamat
week.
berjumpa.
Dr. Jeff.
Ya.
Pak
Ervin,
Awang,
thank you
siap.
Pak Ervin. Jeff, thank you.
Sehat-sehat, Pak Yan.
Bung
Kasih, Pak
Justi
Yusti.
minggu depan ya.
Siap. Siap,
Pak Ervin, thank you Pak Ervin.
Siap.
Thank you, Pak
Ya,
Ervin.
Pak Jus.
Thank you.
Kanda Prof, makasih. Siap.
Pak Ketua,
Pak Ervin, thank
selamat.
you.
Ya, Prof. Yan, makasih Pak Awang. Terima kasih
Yuk.
Pak Awang. Iya, iya. Pak Jeff?
Pak Adi,
Yuk, sampai
Awang.
nanti.
yuk Pak Adi.
Siap.
Sehat-sehat, Pak
Salam.
Awang.
Sehat, baik Pak.
Pamit ya.
Siap, Prof.
Pak.
Saya juga pamit. Oke, terima kasih semua.
Terima kasih,
Terima kasih,
Pak
Pak
Jeff.
Jeff.
Ya,
Thank you
terima
again.
kasih, Pak Jeff.